We're going to start with 1.1. So the first thing here is a definition of a function. A function is a rule that assigns to each element x in a set D exactly one element called f of x in a set E. So it's a rule. A function is a rule. Basically, it takes in a number, spits out a number, right? The domain of a function is the set of values which may be evaluated at or all allowable points of the function. So we've seen in the past in college algebra and in pre-calculus, there's certain things you can't plug into certain functions, right? Like if you have the square root of x as a function, you can't plug negative numbers in. So the domain is everything you can plug in. Let's see who remembers some pre-cal. What would be something you cannot plug into the function f of x equals secant x? Secant x. So if I take f of x equals secant x, someone give me a value, a number that is not in its domain. Anybody remember what secant x is? 1 over cosine. 1 over cosine. So this is 1 over cosine x. Good. Now, what could potentially cause a problem if I have 1 over cosine x? If I have 0 in that denominator, right? So if this denominator here, cosine x, is 0, I've got problems. So maybe I should look at that. When is cosine x 0? So where's cosine 0? Dun, dun, dun. So are you thinking unit circle here? Straight up, 90 degrees? That's correct. 180 also. Or not 180, you're 270 straight down. Yeah. So if x is 90 degrees, or let's do radians, pi over 2. And another one would be x is 270. Or what's that, 3 pi over 2? And actually, there's infinitely many, aren't there? Those are things that would not be in the domain. All right, let's get back to it. So the domain is basically everything that can be plugged in. The range of a function is, for each value we plug in, something comes out, right? As long as we can plug it in, there's something that comes out. If we take everything that comes out of the function, that's called its range. It's all the outputs. Okay, now the concept of independent variable versus dependent. The variable which takes on the values from the domain, oops, there's going to be typos, okay, sorry. Domain, I spelt it wrong. Usually x is called the independent variable. It's independent of the other variable in the equation. The value is independent of the other variable in the equation. So x is what you plug in, and what's the dependent variable? The one that comes out, right? The y. We usually have an x and a y, or x and f of x. So in order to know what y is, you have to know what x is. So y depends on x, so y is the dependent variable. Graphs of a function. The graph of a function is a visual representation of all the inputs and their corresponding outputs. It is the set of all ordered pairs, and then I've got this thing over here. What the hell does this mean? Well, yeah, this is like a point, like the point 2, 4, right? The x and the y coordinate. It's all the x and y coordinates for every x. That little symbol means element of what? The domain. So for everything that you can plug into the domain, all the outputs, write them out as points, ordered pairs. That's your graph. So the first way we ever learned to graph something was by doing a t-table. Remember this method? You would have like y equals f of x equals negative x cubed minus x squared. So let's do this by graphing 5 points. Let's just pick some points. So what's the independent variable here? What's independent? X. And the dependent one is Why? So if I plug in an x, and I just picked -2, right? I could have picked anything I wanted, but I picked -2. All I have to do is plug -2 in here, blah, 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 and it would spit out 4, right? Then I could plug in -1, it would spit out 0. If I plug in 0, I get 0. If I plug in 1, I get -2. If I plug in 2, I get -12, right? If I plot those 5 points, this is what I get, right? Get that graph right there. Those are my 5 points. Everyone's comfortable with that, right? Now, 5 points is sometimes 5 points is enough for you to know what it looks like. But a lot of times 5 points isn't enough. So this is that thing I was showing you earlier. I'm going to bring this thing up. There are the 5 points, right? If I had done 25 points, now I get a better idea of what it looks like. If I do 50, there's even more, 100. But who would want to plug in 100 points, right? And then the actual function itself, I'm going to take all those points out. You can see it's that red. And I'm kind of disappointed. This projector in this room sucks. There's some good projectors on campus that you can really make out the colors. This one's not one of them. So, all right. Okay, next idea. This is the concept that f of x, right? That's the output, is the height of the function at a given value. The height being the height if you measure it from the x-axis. I'm going to blow this one up pretty good here. So on this one, you can click and you can drag your value of x. So here's x, right? X is actually like negative, boy, you can't see it there, can you? Negative 2.6. And the height of the function there is this blue line. That's the output, 3.4. So the output is how high you are off the ground. So is the output here positive or negative? Positive, right? Because I'm above the x-axis. And if I move over just a little bit to the right, I'm still positive, right? At some point, though, my height is actually what? Like right in there. I can't get right on it, but you can you can open this up and you can actually put in a value if you want. So there, at 0, what's my height? 0. If I keep moving to the right now, my height is actually a negative number now, right? Because I'm below the x-axis. All right, so we just want to make sure that we understand that the output is the height of the function. Vertical line test. What do we use the vertical line test for? To determine if it's a function, right? So to test if a graph represents a function, that is to say that y is a function of x, we apply the vertical line test. If any vertical line intersects the graph more than one point, then it's not a function. So is this one a function? This is a function because if I pull any vertical line that I draw, right, it will hit it no more than one time. Now if I click on graph B, now I have another function. Now look at my vertical line over here. It's not hitting anything. Is that okay? If you draw a vertical line, you do not hit the graph. Does that mean automatically you're not a function? No, this basically doesn't tell you anything. Right now, I can't tell you. It could be a function still. How about when I move this thing right on top of that? I can't get it. Right on top. Is that a function? How many times do I hit it here? Once. That's okay, right? But as soon as I go to the right of 0, I'm done. And my line turned red to let you know, oops, not happening anymore. So I hit it at 2 places. This fails to be a function. Everyone, I think, has probably seen that. Piecewise functions. Any function that is defined to be different functions on different ranges of the domain is called a piecewise function. So here's an example of a piecewise function. So what this is, this says f of x equals x squared plus 1 if x is less than or equal to 1, and negative x squared plus 2 if x is greater than 1. So what you have to understand about piecewise functions is that there's usually a separation where you have one function that turns into another function. And our separation here happens at what x value? At what x value? At x is 1, right? If I come out here to x equals 1 right here, that's where my function, to the left of 1, it's this guy. And if it's to the right of 1, it's this. Now, why is there a solid dot here and an open circle here? Okay, so and these two pieces right here where we define our domain, it says if x is smaller than or equal to 1, you want to plug in here. So if I plug 1 in, I get 1 squared plus 1, which is what, 2? So I put a dot here, a height of 2. But I do not put anything here. What if I had a solid dot here and here? It would fail the vertical line test, wouldn't it? And it would no longer be a function. How many of you have seen piecewise functions before? Okay. Every once in a while I have to check to make sure my audio is on. All right. Intervals where a function is positive and negative. So now we get into some stuff it's going to be important in this class that you understand how to write down intervals. So a function is said to be positive on an interval I if the function is bigger than 0 there. That just means that if the height of your function is above the x-axis, we say the function's positive. If the height of the function is less than 0, it's said to be negative. That means below the x-axis. And if it's actually 0, then it's said to be 0 there. So let's look at this function here, and let's see if we can't determine where it's positive and negative. So where is this function positive? So I'm saying, where's the height of the function? Where is it above the x-axis, right? That's right in here, isn't it? So from this x value to this x value. Can you tell what x value that is? I think this is a -5, right? So -1, -2, right? So it looks like from -2 to where? 0. Now, when you talk about intervals, you're talking about the x values. Where is it positive? Between the x value of -2 to 0. Now, where else is it positive? Well, from 0 to 2, it's negative, because it's below the x-axis, right? But from 2 on, it's above the x-axis, right? So here's where I can click on this. And again, the color's not going to come out very good here, but right here, this green, and then this green right here. And then what I did is I put the interval in red over here. And man, that's really hard to see. I'm going to blow this up just so you can see it. That interval right there, that's the way you write it. X is an element of parenthesis, -2 to 0, close parenthesis. What's this symbol? Union, parenthesis, 2 to infinity, parenthesis. Why am I using parentheses and not brackets? They're intervals, but what's happening at -2? What is my function's value at -2? Y'all see my arrow? What is it? 0. Is 0 positive? No. So I don't want to include -2, so that's why I put a parenthesis, not a bracket. And then what's the value of the function at 0? 0. 0 is not positive, so I don't want to include 0, so I put a parenthesis. Same thing with at 2, right? At 2, my function looks like it's 0, so I don't want to include that. And then what about infinity? You always put parentheses on infinity, always, always, all right? Now, where's the function negative? See if you can jot that down yourself. Like, give me the interval answer. What I mean by interval answers, you know, x is an element of what? Uh-oh.